Hello all, this is Aishwarya. I welcome you all for this session. It's about SAR, that is Successive Approximation Type ADC. So it is the most commonly used ADC because in this ADC we have to convert that analog input into a digital output in a EC method. Okay, so let us see how it works. So this is about the construction of this SAR register. So in this SAR register the three main components are present. So one is comparator, another one is SAR register, and next one is our DAC. Okay. So and in this SAR we have three input. One is comparator input is given to this SAR. Another one is start of conversion signal. Another one is clock signal. Okay. So whenever we turn on the SOC signal, that is start of conversion signal, that time the process of conversion is started. Okay. So once the conversion is end, that time we have to enable this end of conversion. This is the procedure. Okay. So let us see how this works means. So in this comparator we have to apply this analog signal, that is BA, to this comparator. After processing, or is after comparing, that signal is given to this SAR register. After conversion, this SAR register will be give the digital form of output, that is D1 to D8. So we have to take the digital form of output in this time, and again we have to send this digital signal to this DAC because the comparator need two input. So one is D8 and another one is this converted output, that is VD. Okay, this VD signal is given to this comparator. Okay, this is for the construction and the process of SAR. So how it works? So initially we have to apply 212 input to this successive approximation unit, or this comparator. So this 212 is applied to this comparator. So in this condition, the signal of 212 will be higher than this inverting terminal, so that the comparator will goes to on condition. So in this one signal is given to this SAR register. So this time the P1 will be goes to high value. Remains are 0. Okay. So that signal is given to this output stage, so that we will get 1 0 0 0 0 0 0 input. Okay. So same this signal also given to this DAC. So this DAC is convert this digital formation of signal into an analog signal, that is 128. Okay. So this 128 signal is now given to this inverting terminal. Again this comparator will compare the two values, that is 212 and this 128 value. Okay. So in this time the same 212 value is higher than 128. So again comparator will be turned on, so that next digital will be turned on, that is 1100. See this 110000. So same value is given to this DAC unit. So in this condition, that value is converted into an analog wave, that is analog signal, that is 192. So again we have to apply that 192 signal into this comparator. So same process will be continued. So in this time the 212 and 192 will be compared. So 212 value is higher than 192. So again comparator will be turned on. In this time third bit of this digital wave also turned on. So 111000 values we will get, right. So in this condition that signal is given to this DAC. Again the DAC is convert the digital form of signal into an analog form. So 224 signal is we will founded by using this DAC. Thus 224 signal is given to this inverting terminal. So in this condition the 212 is lesser than 224, so that the comparator output is 0. Okay. So in this condition we have to change the third bit value into 0 and we enable the fourth bit as 1. Okay, that is the third bit value is complemented, so the 1 is complemented by 0 and the next bit will be turned on. Okay. So same process will be continued, and in this condition the next value is 208. The 208 is given to this 212. Same, the 212 will be higher than 208. So comparator will be turned on, the next term will be enabled. Okay, so the same condition will be maintained until this condition. So again 216 will be applied to this comparator. In this condition 216 is higher than 212, so the comparator will be goes to 0 condition. Same process, that is the previous bit value is complemented and the next bit value is incremented. Okay, so the 212, again the last one is 212. So whenever the both input are same, that time the comparator will be turned off, and as well as SAR register will stop that conversion, so the EOC will be enabled. Okay, so this is what the process of SAR register. So initially we apply the analog input to this comparator, and we will, after processing, we will get the digital formation of value by using this SAR register. Thank you.